Hello, everyone, and welcome to today's virtual field trip, Wastewater Treatment and Resource Recovery, Part 2, with the South Cross Bayou Water Reclamation Facility. My name is Jacqueline Drakis, and I'm the Expeditions Manager for EarthEcho International. And we are a nonprofit founded on the belief that youth have the power to change our planet. Our free programs and resources have reached more than 2 million people in 146 countries. Now for today's virtual field trip, I wanted to give you all a reminder that you can send in questions anytime for our amazing host, Shay, and we will get those answers throughout today's event as we're able to. If you're joining us here in Zoom, please use the Q&A app or feature to enter your questions. And if you're watching us on YouTube, you can go ahead and enter those questions in the chat, and we'll try to get to as many as we can today. Now with that, I'm so excited to introduce you to Shay Donovan, who is going to share with us all about what happens when and how her and her team are able to turn our number twos into plant food. So Shay, go ahead and take it away.
Oh, sorry. It's not every day you get to go on YouTube with a hat on like this, so you got to rock it. Well, good afternoon or good morning, everybody, depending where you are. My name is Shay Donovan. I work for the South Cross Bayou Advanced Water Reclamation Facility, and that is a very long name. And so for today's expedition, we're going to be talking about one of my favorite subjects, strangely enough, and that is this. So without further ado, today, we're going to be doing from number 2 to plant food, right? So during today's presentation or expedition, we're going to have a little game going on. So here's a nice little warm up for you. We're going to be playing a game called What's SCAT? So as opposed to saying, what's that? What's SCAT? So if you'd like to play along, here's a good way to play. If you want to type in the chat, what we'll do is we'll put up a picture like this one, and you can guess what animal this SCAT belongs to. So if you've never heard the term SCAT, by the way, SCAT is an animal fecal dropping. So with that, if you'd like to play along, go ahead. We'll go ahead and kick this off right. So what animal do you think this SCAT belongs to? So who's SCAT?
So we'll give everybody a couple minutes to kind of put their guesses in the chat. Let me see.
If you all need a clue,
maybe a clue.
A good clue for this one. This is a large wild animal. Not a human, definitely not a human. There are no human answers in here, by the way. Wildlife. So what do you think this SCAT?
I think Allie on YouTube might have it. She's guessing deer.
Ooh, good guess. Yay, this is a deer. Very good guess. So yes, this is in fact a deer SCAT. So there's going to be plenty more of these where this came from. That just sounds wrong, but there will be plenty more of these where that came from. So to kick it off, the first one was deer. Good job. So every great story begins with once upon a flush. So hopefully you all knew that this is the direction that we were going in on today's expedition, but I promise it's going to be a fun one. So let's start with the tagline, once upon a flush. So I work in an industry that's pretty unique. So for most of us, including myself, we probably go to the bathroom several times a day. That's normal. That's good, by the way. But the average American uses about 100 gallons of water a day. And that is actually a lot of water. And so when you think about when you're in your home or you're at school or you're in a business and you're using water, what room of the house do you think you use the most water in? Surprisingly, most people use the most water in the bathroom. Think about it, because you go to the bathroom several times a day, you flush the toilet, and then you all wash your hands. You better be washing your hands, by the way. We also take showers and baths, and so that generates a lot of what's called wastewater, right? So regardless of whether you're taking a bath, you're flushing the toilet, you're washing your hands, or even if you're in the kitchen and you're washing dishes or you're doing laundry, all that water that you use inside your homes and your schools and your businesses inside the building has to go down a drain, and it has to go somewhere, right? But what happens is when all that water gets mixed in with raw human sewage, like this, we now generate what's called wastewater. And that wastewater has to go somewhere. So on the right-hand side of your screen, you'll see a picture. If you live in Pinellas County, Florida, your wastewater might go here. Depending where you live, your water, definitely if you live in the US, it's probably gonna go to some sort of facility. That doesn't include people that live on septic tanks. So if you're not sure, Ask your parents, ask your teachers, ask around. People can help you with that. So here in Pinellas County, this is the South Cross Bayou Advanced Water Reclamation Facility. And this is where I work, and this is where I'm sitting right now. So a little bit more about that to come. So before we get into the fun stuff about all the number 2 and the doo-doo that we do here, I just want to bring up a really good point about why it's important to treat wastewater. So again, if wastewater is all that used water that goes down the drain in our homes, in our schools, and our businesses, and it has to come to a facility like this one to get cleaned, or we say treated is the technical term. If you look at other countries around the world, it's not always a good condition. So for instance, this is kind of a sad picture. This is actually comes from India. India is a developing nation. They don't have the facilities like we do here in the United States to treat their water. So for instance, in this picture, if you look at the water, you notice that it's kind of green, it's brown, it's not exactly the kind of water that you or I would exactly want to play in or drink from or bathe in. But unfortunately, in a lot of countries around the world, we take for granted as Americans that these aren't the conditions that we live in. And so I know that sounds sad. The good news is there is hope. We can start by educating, and we can start by working with our neighbors in other countries to help them build these facilities and educate them so that they can move in the right direction. So the point here is why we treat wastewater is because we want to avoid conditions like this. Could you imagine if you had to drink the same water that you bathed, you washed your clothes, and maybe even your local neighbors put their sewage into? It's not a good thing, right? So that's exactly what we're trying to avoid by creating facilities like this. Now, the word wastewater is in itself a bit of a misnomer, meaning that it's not exactly, it's kind of a deceptive term, because when you and I think of waste, we think about something that goes in the trash and it goes away, right? But instead, what we do here at our facility is we say that not all wastewater is actually waste. So let's think about that for a second, right? You've got this wastewater that's full of human sewage, it's got toilet paper, it might have other garbage in there, but when that comes to a facility like this, we actually look at it in terms of what are the resources inside that wastewater. Sounds strange, right? But we can actually recover resources from that wastewater. So for instance, if we look at the screen here, you'll see a picture of that brown wastewater that's full of human sewage, right? Ooh, gross, I get it. We clean that wastewater, and that takes about 24 hours. We create what's called reclaimed water. And if I hold this bottle up, you would never have guessed that this actually contained human sewage at one point, would you? No, that's how good we are. I hate to say it, I'm bragging just a little bit, but we are that good. So we take all that wastewater, we treat it, we make it into reclaimed water. The other thing that we do is we create fertilizers. And if you haven't guessed where the fertilizers come from, yes, you all are little fertilizer making machines. Congratulations. Nobody's probably ever going to say that to you again. So that was kind of cool. And the other thing that we do at our facility is in the process of making this fertilizer, we use a lot of bacteria. These cute little bacteria like this one. This one isn't such a good guy. This one might actually make you sick and give you an ulcer. But we have a lot of bacteria in our wastewater. Part of that comes from all of this, and some of it is just naturally there because in the environment, there is a lot of bacteria in the soils and in water, and they're not necessarily all bad. So we put these bacteria to work, and that helps us create this at the end of the day. But they also generate a lot of gas in the process, and we collect that and we use it as energy. So that's what we call resource recovery. So before we go on any further, let's just make sure we're all on the same page as far as what we're talking about when we say biosolids. From here on out, I will be referring to this as biosolids. And what's important about biosolids is that, yes, all of us go to the bathroom. I know, even I chuckle about it, right? We all go to the bathroom and it ends up at a wastewater treatment facility like this one. Well, what happens is as we're treating that wastewater, in other words, as we're cleaning it and it's moving through the processes, there's an accumulation of solids in there. And that's interesting because 99% of all of our wastewater is in fact water. 1% or less is actually solids. Think about it, when you flush the toilet, most of this falls apart, right? So when it gets into a facility and it moves from one process to the next, to the next, to the next, it tends to accumulate in the bottom of the tanks. And that's not what we want, because at the end of the day, that accumulation, those solids are taking up space. And we want to keep that space so that we have water coming in. Because remember, a wastewater treatment facility never shuts down. It is a 24 hours, 7 days a week, 365 days of the year operation. There is no on and off switch here. As long as people are using water, we have to be ready for that water. So as that's happening, we're constantly reacting. So for those of you who live in Florida, last week we had a tropical storm, which meant even more water was coming into our facility. So we are always reacting to what's going on around us, not just the water from our homes and our businesses, but also the environment, like heavy rainstorms. So what does it mean to have biosolids in Florida? Now, this is an interesting topic, and it might be one that you've never really thought about. Okay, so you flush the toilet and your number 2 goes away and it goes to a treatment facility. And then that almost seems like it's kind of the end of the story, right? Well, that's not exactly true. For instance, here in Florida, what happens to the fate of these so-called biosolids is regulated by the Florida Department of Environmental Protection. And that's important because anytime you are dealing with something that could potentially make people or the environment sick, you have to have regulation. You have to have government involved because you have to protect people and you have to protect the environment. So here in Florida, for instance, what happens to those biosolids? There's one of 3 fates usually. The first one is that once we treat the wastewater and we remove those biosolids, we can spread them on land. So we call that a land application. And you might be thinking, that's disgusting, that's gross. But again, remember that this is actually a natural process. And I'll get into that into a minute. So we can spread that on the land, and it's what we call a soil amendment. It actually helps the soil out because there's bacteria in the soil, and they're going to start to eat away at that. Sounds gross, but again, bear with me. This is really cool when I get into it, I promise. The second fate is that we can send it to a landfill. Now, why we would send it to a landfill, for instance, in like a rural community where there's a small population, it might not be economically feasible to actually make a fertilizer or spread it on land. It might be a small population. So it would be cheaper to just send it to a landfill and be done with it. And then the third fate is that we can actually make fertilizer like what we've done here. So I'll try to hold that up. These are like little pellets. The problem with this is, well, one, you have to have special equipment. So you have to have a special facility to actually produce this. So that means you've got to pay people, you've got to build a facility, and you've got to put a lot of energy and equipment into this. So for a small rural town, this might not be a very practical solution. So keep in mind, different parts of Florida and the US treat their biosolids differently, but all of them are regulated by some sort of government entity. So speaking of Florida, we have a lot of agriculture here, and we are well known for our citrus, right? So if you look at this picture here, this is a make-believe Florida farm, right? And on the left-hand side, you can see there's some citrus trees with some healthy oranges growing. This farmer is using bags of fertilizer. So again, keep in mind that plants have to eat too. It's not a conversation we think about every day, like you and I eat because we have to sustain our bodies, right? Well, plants have to eat too. But the problem is when you can't exactly get up and walk and catch your food, where do you find your food? Well, plants have to find those nutrients in the soil. So a lot of times when you have crops, especially those that are producing fruit, they need a lot of nutrients. So farmers have to put down bags of fertilizer, right? Well, let's say that this farmer decides that he doesn't want to use fertilizer anymore. So he stops using it, right? Now, if this farmer was to stop using fertilizer, can you look around this farm and see another possible source of fertilizer? Maybe something that walks. So if you guessed either the cows or the pig, and hopefully not the farmer, hopefully he wouldn't do that. But in other countries, they actually do use human waste. True. So all of these animals, they generate waste. But again, right here, we're talking about waste as though it's a fertilizer. It's a source of nutrients. And while that might seem gross, it's actually very natural. there's lots of nutrients in our number 2. And that's kind of what we're talking about today. So I know what you're thinking, maybe. How do we get from all that wastewater to a fertilizer product? So in other words, we're going from 99% liquids with 1% solid, this, to a fertilizer. Well, the short answer is that it's STEM, science, technology, engineering, mathematics, all of that is involved. And I could go on for days and days about it. There's so much involved. It's really mind-blowing. I've been in this industry for 4 years, and I still feel like every day I learn something that I didn't know yesterday. It is so amazing. And what's really cool about this industry is that it's modeled after nature. We use science that is kind of like what we study about our natural environment, and then we build an engineered system that models that natural process. So really cool stuff.
So Shay, we had a question come in from Mr. Miller's class, and I thought it'd be kind of appropriate to ask before we get into the stem of the fertilizer. And that is, do you use animal number 2s like moose or elk or deer in this process, or is it strictly just the human waste in the wastewater?
That's a good question. So what we do at our facility is we work specifically with human. And so yes, elk and deer and moose and all that contain nutrients in there, but there is kind of a perception of, like, for instance, if you have wild animals, we don't have the populations of wild animals that we do of people. So think of like big cities like New York. If everybody was going to the bathroom outdoors, like, okay, just gross, right? It would be out of control. So part of that's a very practical answer, just because human population is so high. Also, we understand and we know a lot more about the spread of disease between humans. So really what we're trying to do is prevent the spread of disease, say, from humans to other humans to the environment. So we do not use any other animals in here. We only use literally the wastewater that comes out of a building like a house, a school, a business in our facility.
Awesome. Thank you so much. And great question. We'll pause in just a couple minutes for some more questions too.
So this is a picture of the South Cross Bayou Advanced Water Reclamation Facility where I work and I currently am. And just a couple numbers, because I think it's really interesting to give people a perspective. We are not the largest facility in Florida. We are located in St. Petersburg, Florida. So we are directly west of Tampa. Over in Tampa, they've got facilities that are 3 times the size of this one. So again, it depends on the size of the population of the people that you're serving. So in our facility, for instance, we treat about 33 million gallons a day. That's kind of where we are. That can be a little higher, that can be a little lower. You have to realize in Florida, we have a lot of snowbirds, people going back and forth. So our water levels are going to fluctuate from day to day, which is why we're always on the pulse of how much water is coming in and out of our facility. We are 35 acres in size, which is pretty big. So you're looking at our facility from north to south right now. We're pretty long. We also produce about 4.4 billion gallons of reclaimed water a year. Again, reclaimed water is what we do once we treat the wastewater. It is not drinking water. So the water that we produce after we clean the wastewater, we use for plants. So it's plant water, right? Plant water and plant food. We also produce about 6,000 dry tons of fertilizer each year. So 6,000 dry tons of this. That's a lot. And last, we also have about $140,000 in energy savings a year from biogas production. And so when we talk a little bit about how we actually break down the solids in wastewater, I'll kind of touch upon that again. But pretty big numbers, pretty impressive numbers for a facility like this. And that brings us to our second round of Who's SCAT? So if you would like to play along, feel free to put your answer in the chat box.
Yes, and if you're in Zoom, you can put it in the Q&A feature. And I'm gonna give you guys a second to look at this picture, and then I'm gonna stop sharing so we can see what guesses we have coming in. So whose SCAT do we think we have today? Let's see.
Do we need a clue?
We might need a clue, I think. Let me put it back up if you want to give us a clue.
So my first clue to all of you is if you look at the ground underneath that SCAT, that is not snow, that is white sand. So we're talking about an animal that likes to burrow or dig itself in the ground.
Okay. Let's see if that helped.
It's definitely a Florida native. So if you live in Florida.
Ooh, okay, so we have a guess of a beaver. I see a horse, a porcupine.
Ooh.
Not sure. Emu, it's an interesting guess. A mole, a bear, and I see a couple guesses for turtles and lizards.
Ooh, keep thinking about turtles. Not quite a turtle, but what's a land turtle? What do we call turtles that live on land?
We have,
Really
armadillo is a good guess for in the
Ooh.
sand in Florida, right? Ooh, tortoise.
Yes, this is a special kind of tortoise though. This one is a gopher tortoise. So gopher tortoises are really cool. They're native throughout Florida and they're like big tortoises, not really big, I shouldn't say that. And they burrow, they dig holes in the ground, right? And they live inside these burrows and they actually share those burrows with other species, like sometimes snakes and rats. So they're what's called a keystone species. If you don't have a lot of gopher tortoises, their populations drop. That means the populations of the snakes and the rats and the other things that they often share their burrows with are probably declining too. So we call that keystone species.
Awesome. I actually have, of all things, a gopher tortoise shell that I found in Florida here at a park, and I cleaned it and brought it home. So they're really cool creatures. All right, so let's get back. Oh, we're going to take a question break. So we'll give people watching on YouTube and those in Zoom a minute to put any questions that you have for Shay. And I did see that we had some come in already. So let me pull some of those up. Oops. So we do have a question. Which building are you in the facility?
Oh, which building am I in? I am in what's called the Public Education Center. It's the front building. So when you come into the facility, the first building on the left, that's where I hang out.
And we do have a question from Evelyn, and she would like to know, are you doing any testing of water for COVID-19?
Yes, absolutely. So we are a part of Pinellas County Utilities. Pinellas County Utilities is testing for COVID in both of its wastewater treatment plants. So South Cross is the larger facility that is owned and run by the county. Our Dunn facility is to the north of the county. We're also testing for we're testing for COVID in wastewater at both facilities. Absolutely. Yep.
Great question. And thanks for sharing, Shay. So that question came from Evelyn. And she's watching with her third graders from Behringer Academic Center in Charlotte, North Carolina. And her students are watching virtually on YouTube. And they're studying urban water challenges. So thanks for joining us today. It's really great. We're so happy to have you here. And we have a question from Zoom, and that is, can you get any viruses from working in wastewater?
Yes, in fact. I've got all kinds of stuff on my desk. We have things like hepatitis in the water. So by the way, these are called giant microbes. You can look them up online and buy them. We have things like hepatitis in the gowater. Let's see what else. We also have viruses that attack bacteria. We call those colophages, if you want to be technical. I forget my camera's over here. So here's this guy, right? It's a pretty creepy looking virus. But yes, you have to, there is a danger with working in wastewater if there's human sewage involved. The reason is that when people go to the bathroom, they oftentimes shed virus through their skin cells. So when you're wiping, yes, that's how you get skin cells in the wastewater. But yes, you can spread viruses through wastewater, which is why everyone who works here, you have to be super careful. You have to wear proper protective equipment. We call that PPE. So yes, there is a danger in working around wastewater. So you have to be very careful about what you're doing. Absolutely. Mm-hmm.
Great question. Thanks for answering, Shay. So Mr. Miller's class is from, I hope I don't say this wrong, Kelowna, British Columbia, and they're learning about sustainability. And a question coming in from his class is, what is the largest item that has ever entered your treatment facility?
Ooh, largest item. We actually don't get a lot of large items coming into our facility because at the front end of the facility, there's a large pumping system that pumps all the water into the plant through these huge, they're like 36 or 42-inch pipes. They're big, right? Diameter. At the end of those pipes, so once the water gets pumped in, they then go through a grinder and we grind the water out. So we pulverize it. And the reason for that is our first defense against if people put things down their toilets, or even if they lifted a manhole cover. That's even worse, right? So don't do that. So that is our first line of defense against large objects entering the facility. So most things don't get past the grinders. If, for instance, there was a wrench or something in there, chances are it would stop up the grinder before it would get into the facility. So I've heard stories about tools. That's why I brought up the wrench. But other than that, I've seen fragments of things that have come through, and I see a lot of cell phones, actually. I've seen a couple of cell phones in my days. So I don't know if people were just sitting on the toilet and their cell phone fell out, or they just had a bad breakup. I'm not really sure, but we don't really see large objects.
Thank you. That's pretty funny. So we have a question from Micah coming in on YouTube. And can there be, I think this is an interesting question. Can there be the same kind of poop or number two from different species?
Different species of...
We all have our unique SCAT, right? Our unique number.
Well, again, remember when we talked about what we do at this facility is we deal with human waste. So we're talking about a sewer system that then comes to our facility. That sewer system is connected to your city. So it's going to be connected to buildings. So unless you're flushing animal waste, probably not.
Okay. And then we'll do one more question. We'll come back for questions later, and we have some more SCAT quizzes. So don't worry, you'll have time to participate in those. But the question is, in the filters that you use, how many filters are there? So I think the question is about the layers of a filter. Can you address that with how you treat the water?
So we actually did a whole video series on the wastewater treatment back in May. So if you have not seen the EarthEcho wastewater treatment and resource recovery part 1, I recommend that you watch that. It is about an hour long and it goes through the whole treatment process. So we technically don't use filters the way that you're thinking. You're probably thinking like a filter, like dirty water comes in and it goes through a series of filters. That's not really what we do. One thing I can show you, I have everything on my desk. We use these things called bar screens. So you can see that the holes are actually pretty large. So once all that wastewater comes in, it goes through those grinders. We actually use these screens to capture trash on it. This is probably the closest thing that we have to a screen, because what happens after that, when we go after all the chemicals and the bacteria and the solids in the wastewater, we use chemistry, we use physics, we also use microbiology. So the only other set of filters I would say, so this is actually called a bar screen. We don't even call this a filter. Right before we're finished treating the wastewater, we put the water through a series of what we call denitrification filters. And that helps us remove extra nitrogen from the wastewater. And that's important because chemically speaking, if you put too much nitrogen out into the environment, it can actually pollute the environment. It causes this phenomenon called eutrophication. So it's a nutrient. And remember, that's something that we're trying to avoid. We don't want to over fertilize the environment. We don't want to put all those nitrogen compounds out into our water bodies, because that's not healthy. So that's probably the closest that we have to filters. But again, I do recommend that you watch that first video, because it goes through the whole treatment process step by step by step.
Fabulous. And we'll make sure we link that out. We can put the link in the chat there. All right. So I think we're going to go back to our biosolids and talk more about what happens with them.
So for today, we're kind of focusing on just one aspect of the entire treatment process. So right now, what we're talking about, again, we're talking about the solids portion. We're talking about this, right? We're talking about the number 2. And we call that one of two things, depending upon where it is within the process. We either call it sludge or we call it biosolids. So you might hear me use those terms interchangeably, solids, biosolids, or sludge, and just know that I'm talking about this, right? So once all that wastewater comes into the treatment facility and we start treating it through all these series of processes, at some point we have to start to remove that sludge or that solids, right, from the wastewater stream. So one way that we do that is that we use these clarifiers. And clarifiers allow for the settling or the collection of biosolids or sludge. So here on the screen, I have a picture of two different kinds of clarifiers. And if you look closely at the clarifier on the left, the first thing you'll notice is that it is a rectangular shape. And if you look at the color of the water, it's brown, it's raw. So this is right towards the beginning of the treatment process versus the secondary clarifier in the middle. It's a round tank. If you look closely, the water looks blue. If you look really closely, you might even notice there's some birds in there. Yeah, because that water has gone through most of the process. It's actually pretty clean, but it's not done yet, okay? So what happens in these clarifiers, I actually have a little demonstration here with a bottle of water. So I've put some glue in here, some glitter, and I'm going to shake this up. And what's going to happen with time is that all that glitter is going to settle. So in other words, if you think about this, it's going to start settling with time. It's going to fall towards the bottom of those tanks, those clarifiers, right? And it's kind of like cleaning a swimming pool. If you have a swimming pool, you know that when things start to collect on the bottom, you can scrape it or vacuum it off, right? Versus if something floats on top, you can skim it off the top. So for those of you who really like science, I'm talking about density here. Things that are heavier than water are going to start to sink with time. And that is the purpose of a clarifier. You can either skim things off the top because they're less dense than water, or you can scrape them off the bottom because they're more dense than water. So pretty cool little thing here. So again, the goal is that we want to collect this, right? We want to start to collect this. And the image on the right, I've circled those tanks on there. But again, if you look closely at that aerial view of our facility, you can tell there's a lot more processes going on. And one thing that I didn't really touch upon, because I touched upon it in our last presentation, is what's happening between the primary and the secondary clarifiers. Between the primary and the secondary clarifiers, you'll notice that the water goes from brown to blue. And the reason is because we actually take all that wastewater and we feed it to hungry microbes, which is why I think wastewater treatment is way cooler than water treatment. And I say water treatment like I'm talking about drinking water. In our processes, we actually take that wastewater and we feed it to all these hungry microbes, right? Some E. coli, some of these aren't some good ones, I can't lie. We got Giardia, we've got Salmonella, we've got all kinds of microbes in the water. That's not to say that some of these microbes or these bacteria are necessarily bad. We also have things like parameciums in that water. So you see these little organelles in there. So these guys, or gals, or whatever you want to call them, are floating around in that wastewater and they're hungry, right? So they're looking for a source of carbon. And what do you think this is to them? It's carbon, it's food. So they're going to eat away at all of this and they're going to start breaking it down into little pieces. And as they're doing that, they're also kind of growing these colonies and they're growing bigger and bigger and bigger. So eventually what happens is when we're starting to separate this out of the wastewater stream, we're actually starting to separate piles of microbes from the wastewater who got fat eating this. If that doesn't blow your mind, I don't know what will. But basically, this is a giant fecal feast. We are feeding this poop to all these hungry microbes, and they're helping us clean the water by breaking it down into smaller pieces. And we call that sludge. And that's what we're going to turn into fertilizer. Pretty cool. So once we've collected that sludge off the bottom of these tanks through the secondary or the primary clarifiers, we then want to start to focus on how we make fertilizer. And so the goal here at South Cross is to make fertilizer for us. And the first step is that we send that water to what's called the flocculant or the Floc tank. So Jacqueline's playing a video here. You can kind of see this is us looking inside the Floc tank. So as weird as this is going to sound, making fertilizer to me is kind of like baking a cake. I know, probably the strangest thing you're going to hear all day, right? The point is, when you start to mix ingredients, you want that cake to have a certain consistency. You don't want it to be too dry. You don't want it to be too wet. You want to get it to something where it's kind of thick and malleable, like you can work with it. The same thing is true about fertilizer. So there is as much an art to making fertilizer as there is science, technology, engineering, and mathematics, strangely. So what you see here, flocculant, or we call the Floc tank. If we look at the picture on the top left, that is a container, we call that a carboy, by the way, full of polymer. And polymer is a chemical that we add to the sludge. So remember, wastewater is 99% liquid. So in order to make that into fertilizer, you got to kind of thicken it up. Think back to that weird cake example. And if you're thinking chocolate cake, I'm sorry. So you're kind of mixing it, you're thickening it up by adding this polymer, this chemical to it. And that takes place inside the Floc tank. So if you look down, you'll see the picture of the Floc tank. And then the picture to the right of that is us lifting the lid and looking inside. And so there's kind of like a paddle inside that Floc tank that's slowly churning it. You don't want to like shake it up. It's not that, it's like a slow kind of churning because you want it to thicken up. So the point is to add this polymer to the sludge to get it kind of thick. Again, I know that sounds strange, but when you're making a cake, right, you want it to be a certain consistency. It's also true here. So from there, we then send it to what's called the RDT, or the Rotary drum thickener. So you've added the polymer to help thicken it, and now you're going to put it through the drum. So think of a rotary drum like looking inside your dryer. If you open up your dryer, you see there's kind of like this big round cylinder that you put your clothes in. That's also called a drum, right? So we put that polymer in there and it spins around, right? We play that video again. You can see that's kind of spinning around very quickly. So if you look at this image on the far right that says interior, what you can't see is if you were to get really close, there's actually like screens inside this thickener, kind of like what we saw with the bar screens. It's got holes. And the idea is that water, as that sludge is kind of turning, the water is seeping through these holes. So we want to try and extract water from this sludge. We don't want it to be too wet, but we don't want it to be bone dry. Again, this is where that kind of art comes from. And as strange as that sounds, when you work around this stuff like our operators do who run the facility and they see this every day, they actually get really good at pinpointing when the sludge needs to be adjusted. So that's kind of part of their job, is to kind of watch this as it kind of develops and make sure that cake batter, dare I say, it looks good, right? So after we put this through the rotary drum thickeners, if you follow the arrows, we then go down to the pumps. And from the pumps, we go to my favorite place on the entire facility, and that is what we call the egg-shaped digesters, which we'll see in the next slide. I lied. Who's SCAT? So before we go to the digesters, again, round 3, whose SCAT is this? You want to take a guess?
Everybody watching some time to guess. I just want to say, Mike on YouTube said that really blows his mind, how we are having a fecal feast for the microbes. And then Reese said that it's kind of like making ice cream or pudding, which I think is good too. So let's see what we have coming in for these SCAT guesses. We have another guess for a deer, a moose, a bunny, a duck.
Oh, who said bunny?
So Nancy said rabbit, and yep. We have someone in Mr. Miller's class that said rabbit too. Good job.
Yep, so that is a rabbit. I'm glad we actually didn't get into the hints because I had kind of a gross hint. If you've ever had a rabbit, rabbits sometimes eat their poop. And it's a phenomenon called, what do they call that? Coprophagy. I could spell it out. So basically, sometimes rabbits eat their poop. They poop twice. So sometimes they poop and it comes out green, and then they eat it, and then they digest it, and they poop it out again brown. I know that's really strange. I had a rabbit once, and I thought there was something wrong with my rabbit. And then I did all this research, and apparently that's kind of a thing. But I'm not a veterinary science major, so beyond that, that's probably as much as I want to know. But yes, rabbit is correct. Good job. So back to my favorite place in the entire plant. These are what are called the egg-shaped digesters. So the image on the left, there's actually 3 different structures. So on that bottom image, if we go from right to left, that first building that looks kind of like an onion, like it's round and it comes up, that is called the egg-shaped digester. And that's also what's in the image on the right. You're kind of looking at it from the north side. The building in the middle, I shouldn't say building in the middle, the structure in the middle that looks like a birthday candle, we call that the flare. And if you look closely, you'll actually notice that there's a flame coming out of it. And then the structure to the left of that is what we call the gas holding cylinder. So remember, these are called digesters. So that should automatically make you think of a certain part of your body, right? Your stomach. And what happens in your stomach? You eat and it digests food, right? And it breaks it down into smaller pieces. The same thing is happening inside these egg-shaped digesters. So you might notice if you look closely that these egg-shaped digesters don't have any windows or any doors. That should tell you that the microbes that live inside there are what we call anaerobes. They don't like oxygen. So think about your stomach. We know that there's bacteria inside of our stomach. We also know that they don't necessarily like oxygen, right? They like these dark conditions, lots of stomach acid, not the kind of conditions that you and I would thrive in. But for these bacteria, these are optimal conditions. So what's really fascinating about these structures is that they are engineered after a part of the human body. Think about it, digestion, right? It's also a part of decomposition. So again, the idea here is that we took all that sludge, we thickened it up, and then we're feeding it to these microbes. And for 2 weeks, the microbes inside these digesters, good and bad to us, they're going to be eating. They're going to eat away at the feces. So it's another giant fecal feast, by the way. And this is going to go on for 2 weeks. This microbe is going to come along and eat, and then it's going to die. And then the next microbe is going to come along and it's going to eat this microbe and it's going to die. And then this microbe is going to come along and eat this microbe and it's going to die. And ultimately, strangely as it might sound, that's what we end up with. These are actually the remnants of all the bacteria and all the microbes that ate this. If that doesn't blow your mind, I don't know what does. Because when most people think about fertilizer from a facility like this, they think it's just this, but it's not. It's actually the remnants of all those bacteria that ate this. That to me blows my mind every single time. And that's why I feel totally confident lifting this lid and sticking my fingers in here, because I know that this is no longer human feces. It is the remnants of these poor souls that ate my human feces. Pretty cool, right? So we got a couple of videos on here to kind of give you a different perspective of what these digesters look like. So we'll start with the outside. So again, this is one of our egg-shaped digesters. We're kind of just walking around it. No windows, no doors. This is going to be the gas holding cylinder, kind of walking around doing a 360. So the point of the gas holding cylinder, by the way, you can still play. And then this is the inside, if you will. So not inside the egg-shaped digester, but remember I'm calling these egg-shaped. So they're actually sitting kind of like on a pedestal. You can see the tops of them, but you can go inside a door underneath, and that's where you see that. We call that the apex. So this digester is actually shaped like an egg, kind of sitting on a pedestal. And these are shaped that way for a certain reason. It helps with circulation. And so what happens is all these microbes in there, they're hungry, but they don't like oxygen, remember? And that's important because like you and I, we breathe oxygen and then we respire carbon dioxide. Well, for these microbes that don't breathe in oxygen, they're obviously breathing in other gases, but they're also respiring other gases. So they're exhaling or breathing out gases like carbon dioxide, methane, hydrogen sulfide. And why that's important is because that is an energy source. So remember what I said about we save about, what was it, $120,000 or $140,000 in biogas a year? That's where it comes from. It comes from all these hungry microbes eating and then exhaling out or respiring, us collecting it, and then using that as gas. So this image kind of sums all that up that I just said, right? So inside that digester, we've got all of our hungry microbes eating away. We give them the sludge, right, that we thickened. So all the former this. They're also going to eat fats, oils, and grease, which I'll touch upon in a second. And they produce gas as part of their metabolism. And then the solids, after 2 weeks, we take out, and ultimately we turn into fertilizer. Pretty cool, right? This is like decomposition on like a ginormous level, okay? So fats, oils, and grease. If anyone's ever told you, you should never pour fat, oil, and grease down the kitchen sink. The image on the right shows you exactly why. When fats, oil, and grease go down the drains into the pipes, when they cool off, they harden. And that's exactly what you don't want to do. So for us at our facility, when we're working with like local restaurants that have grease traps, there's actually trucks that go to those restaurants and they pump out those grease traps into their trucks, and then they bring that directly to our facility. So that fat, oil, and grease does not go through the same treatment processes as like the water that goes down the drain in your house. Instead, we put it directly into this system right here. We feed it directly into our egg-shaped digesters. And that's because we don't want to clog our pumps and our pipes. The same way that we tell you don't put fats, oils, and grease down there, we don't want the same problem. So there's actually a heating mechanism in here that you can't see. So as trucks are kind of unloading that fat and that oil and that grease into this tank, we're actually heating it up. So that way it doesn't clog our pipes while we are pushing it into our egg-shaped digesters. And ultimately, that's going to be part of our fertilizer. So I put this slide on here just to kind of show you all that this is kind of like, to me, the recipe for how you make fertilizer. It is a very technical diagram, but I just wanted to show you that making fertilizers is a technical process. There is an art behind it. There is a science, a technology, all of that goes behind this. And so to actually go from now those microbes have been eating away at that sludge for 2 weeks, now we got to make it into fertilizer. You can see that there's several steps that it has to travel through, right? We now call that biosolids. So now that it's leaving those digesters, we call it biosolids. And if you follow these arrows, you'll notice that there's two fates. You see that there's air, and there's also going to be pellets. Keep in mind that pellets are the actual fertilizer. So again, I just kind of put this in here to kind of show you what the recipe for fertilizer looks like at our treatment facility without going into too much detail, because these are all very, very, very technical processes. So I just want to highlight some of the steps for making fertilizer, because as I just said, it's very technical. One of the steps that I like to point out here is dewatering. So you might get some experience when you're in high school. If you take a laboratory, you might work with what's called a centrifuge. And what a centrifuge does is it basically spins around really, really, really fast, right? And that can help you separate out things based upon density, especially if you have large particles in water. Those heavier particles are going to sink to the bottom when you spin it really fast. So in this dewatering and these centrifuges, what we've done is we've now taken all those biosolids out of the digesters. We put them into one of these centrifuges, which are the two big blue things you see on either side of the room. Those are the centrifuges. You put it in there, you spin it around real fast. And the goal is you want to remove as much water as possible. Because the last time I checked, when you buy fertilizer for Home Depot, you don't want to buy something that's sopping wet. So the point is just to get all the water out. From there, we then send it to what I call the fertilizer factory, or Synagro. So this is pretty cool. This is probably my second favorite part of the tour. So let's go inside Synagro and see what happens, and I'll talk about some of these structures in a bit.
Maybe we'll work on that SCAT and I'll see if I can get this video up.
So,
does that sound okay?
Yeah, you're fine. So this here, again, we're playing another round. We have one more SCAT after this, by the way. So this one's a little bit different than the other ones. Again, if you'd like to play along, you know how. My clue is to look very closely at this one. That's fur. So we're dealing with a carnivore here.
All right, let's see as the guesses come in. Oh, a rhino. We have the guess of a wolf and a cow. And let's see.
Wolf is close.
A fox. Or a bear. A cougar.
Ooh, starts with a C.
Oh, we have a request to see the SCAT again. I'm all about that. Let's pull it up. And we have a couple guesses coming in, including Reese from YouTube, who says coyote.
There you go. That is a coyote. Good job.
All right.
Was it the fur? I think it's the fur that gives
I
it
think
away.
it's the fur. Unfortunately, this video is not loading today, Shay.
You're
Can
fine.
we move on to the next one? Sorry.
No, you're fine.
Technology. All right. Good job, everyone. You got the coyote SCAT.
So now we've entered Synagro, which we just saw the picture of, and this is our actual fertilizer factory. So if you would be so kind as to play this video, this is the control room. So I just wanted to show you all this because I think it's kind of cool. So if you're entering into Synagro, this is kind of like the brain of the operation. You see there's a lot of monitors, there's a lot going on, and then all those switches on the wall, there's a lot of things to turn on and turn off. There's a lot going on in this one room. That gentleman sitting inside there probably has a title similar to something of operator. These are individuals that kind of oversee the operations and what's going on. They're kind of monitoring all these different computer monitors, and they're monitoring the processes, and they're making adjustments, but they're also there in case something happens, they can shut it down. So definitely a lot going on inside this room. This is the control room of Synagro. So from there, we then take all those biosolids and we put them into a furnace and a drum, right? So when we play this video, I want you to watch, there is on the right-hand side, it looks like a giant cylinder. It's going to be spinning. That is going to be the drum. So remember, think drums, think big cylinders, if you could play that video. So again, the goal here is that we want to try and get as much water out of the biosolids as possible because we want our pellets to be dry. So we put them in this furnace. There is a furnace that is heating this up. I believe it's 1400 degrees. Temperature is very important here because you want to kill pathogens. And pathogens is a technical term that we use to describe bacteria, viruses, protozoan cyst, anything that can make us sick. So you have to heat those pellets up to make sure that you kill everything because you don't want to risk anything being in there that can make somebody sick, right? So you heat it up really high, you spin it around. Again, the goal here is that you want to dry these biosolids to roughly 90% solid. So you're trying to remove water from this. Again, the goal is you don't want to sell people soaking wet fertilizers. So very, very interesting stuff going on in here. We put this one in here. Now, this is a very technical piece of machinery, but I think it's also very important. This is what we call the regenerative thermal oxidizer. So one thing that we have to think about as environmental stewards is not just the immediate product that we're creating, but also are we creating any other byproducts that could be harmful for the environment? That would include things like noxious gases, right? So the RTO here is very important because it helps us break down what's called volatile organic compounds. It also helps us with, odors, because as you can imagine, when you're working with biosolids, it can be a little fresh. And when you have neighbors, you don't want them to complain. So we have to control our odors, but we also have to make sure that we're destroying any toxins that could create any sort of hazardous air pollutants. So this is a pretty cool mechanism to me. I think structurally it's just cool looking. But again, the idea here is that even though the goal is to make fertilizer, we have to think bigger. We have to think about what other kinds of byproducts or pollutants we could be creating in the process. And so that's what this is designed to kind of combat. And I might have saved this one for last just because I like me some Tay-Tay. You got to shake it off, right? So one of the last things that we have to do with our fertilizer is we put it through this shaker screener. So you go ahead and play that. And to me, it's just a strange kind of looking box. It just shakes, right? The idea is that you want to sort out your pellets by the size. So when you're selling fertilizer, you want your pellets to be somewhat of a consistent size, right? You don't want them to be too big. You don't want them to be too small. So you put them through that shaker and you kind of shake it out, right? And anything that's really small, like dusty, is going to get captured, or anything that's really big can also be removed. But again, the idea here is that you want to create a product that is consistent. And so anytime you're selling something, which we do sell this fertilizer, consistency is kind of key. So if you shake it, and these are the size pellets that fall through the screen, those are going to be the ones that we sell. So that's what we call the good stuff. Here is a nice image of the Synagro or the fertilizer factory. We also call it the pelletizer factory. Something that I want to point out, just because I had grandparents that owned a farm. If you've ever been on a farm, you might recognize these structures here. They're called silos. So these are actually storage tanks. This is where we're storing the fertilizer until the trucks come. We usually get 1 truck a day to pick up a load of this fertilizer. It then usually gets sent to Central Florida where it gets sold. And that's very important because we take those profits, we split them half with Synagro, who runs this facility for us. And then the other half we put back into running our wastewater treatment facility. And that's really important because to run a facility like this, to run South Cross, this 35-acre facility, it costs about $18 million a year. It is not a cheap operation. So you have to make some profits from these fertilizers to kind of keep yourself going. But the cool thing about these silos that I like to point out is if you notice that little white tank on the left, I call it little, that is actually liquid nitrogen. So when you have a lot of fertilizer and you live in a really warm climate, you have to keep your fertilizers cool. And I won't answer why because, well, let's just say that fertilizers and high temperatures are no bueno. And that brings us to our very last What's SCAT? So
our last What's SCAT, and I just wanted to say, Shay, Allie on YouTube said that she lives in a neighborhood near the woods and she sees coyotes all the time, but she's also seen silos at a farm and she wasn't quite sure what they stored. So interesting. All right, let's see what we have coming in for SCAT guesses this time.
They could store other things. Now, depending upon what the farm is doing, they could also store, I think they can also store residues, like if they have corn, they can have harvest. Don't hold me to that. They're not always necessarily just for fertilizers, but silos themselves are considered a sort of storage device. So really the usage could vary.
Awesome. So it looks like we have some guesses coming in. We have deer, we have bird, we have a bear. We have a couple guesses for a type of bird.
Nope.
A bat?
It's furry. I think it's cute. It's got a banded tail. So it's got, you know, like almost like black and gray. So it's got a pattern on its tail.
A mongoose.
Ooh. I think Florida.
A pig. Oh, okay. I see some answers coming in from Mr. Miller's class. A skunk. A possum. We're getting closer, guys.
We're getting close.
I see Alyssa and Reese are getting raccoon. They got it right.
Ooh, we got raccoon, huh?
Yes.
Yeah, that's definitely a weird picture, I know. They eat a lot of berries, but definitely when you see their SCAT, it's pretty unique.
I saw some of this in my backyard the other day, and I thought, I wonder if it's raccoon or possum, but now I think it was raccoon. Thank you so much.
So you all are going to think about SCAT completely differently after this.
I love it. We're SCAT masters.
So very quickly, one last thing or two that I just want to point out. This is the loading dock. So these are just some images we're showing you of trucks that are picking up fertilizer, which we're calling pellets at this point. So there's a loading dock, kind of the images going from left to right. We've got an empty one with a truck, one with pellets. And I just want to point out that if you look on that bottom image, that truck almost looks like it's sitting kind of on a bridge. Well, it's actually sitting on a large scale. So we weigh our trucks when they come in and out. That also helps us with kind of loading and knowing how much is going in and how much is going out. But you might also notice that there's water there. So we have to constantly wash these loading docks because here in Pinellas, we have fertilizer ordinances, which means we have to be very careful about not spilling fertilizer everywhere. We don't want that to get into our local waterways. So no presentation about wastewater or biosolids or number 2 would be complete without a friendly reminder about the things that should and should not go down the drains in your homes. So remember, flushing things like your number 1 and your number 2 and toilet paper, we're totally okay with that. And when you're brushing your teeth or you're washing with soap in the shower or washing your hands, all that stuff is designed to go down the drain. So that's all really good stuff and stuff that we are designed to treat for. And of course, a friendly reminder of all the things that should not go down the drain. Don't put oil, grease, medications, toys. Yes, people put the weirdest things down the toilets, okay? Goldfish. No, please don't send me your goldfish. Remember the whole story about the grinder? Yeah, don't do that. And cat litter. So anything that goes down the drain in your home could potentially end up in a facility like this. So please, if you do anything today, just be mindful about where your wastewater is going and how much work has to go into treating it.
Thank you so much, Shay. So we are running a little over on time because we're just having so much fun talking about number 2 today. But we'll answer, let's see. I think we have a question that we can ask before we say bye today. And that is, have you ever used the clean water? So we're going to go back to water here for other uses like watering grass. My cousin works for wastewater treatment plant in Orange County, and they're finding ways to use filter water from sewage for lawns because of drought conditions.
Mm-hmm. So I assume you mean Orange County, California, or you can mean Orange
so.
County, Florida.
We do.
So the water that we create after we treat the wastewater here, let's grab it here, is reclaimed water, right? And reclaimed water is specifically designed for grass, plants, trees. It's irrigation water. That's what it's designed for. So we actually call this water for plants, where we call this, food for plants. So that's what our facility does. We make food and water for plants. So it is specifically designed for that. It is designed for irrigating. You can use it in decorative fountains. That's okay. But it's not drinking water. In order to make that drinking water, we would have to put it through a whole nother series of processes as though it was raw water from the source, like an aquifer or something. I will say that technology does exist, but the reason that we're not there yet, especially here in Florida, is public acceptance. Try to tell somebody what this used to be and that it might be coming through the tap in their home. And well, we're just not there yet. But in our lifetimes, we're going to be there for sure.
And I can't help myself. I have to give a shout out to Asher and Haven, who are watching us. They're 5 years old. They're watching from Canada. And they would like to know, I think this is a great question and a good wrap up too, is does every facility make fertilizer?
Nope. So again, think back when I was talking about the fate of biosolids in Florida. It depends on the population that they serve, how many people. For instance, if you live in a very rural place in the middle of nowhere, it might be a really small population of people. This is very expensive to make. And as you saw how big that factory was and how many people work there, that's not a cheap operation. So it might be a matter of cost. It might be down to the dollar sign. So no, not everybody makes fertilizer.
Yes. All right. Well, Shay, thank you so much. And thank you everyone for joining us today. I really feel like I could sit here for a lot longer and talk about all this. It's really fascinating. But like Shay said, we have done a virtual field trip with Shay in the past, and that's available on our YouTube. We also dropped that in the chat. So we encourage you to watch that to learn more about wastewater treatment. I would also encourage you all to connect with the Cross Bayou Water Reclamation Facility in Pinellas County Utilities. So Shay was kind enough to give us their socials. You can follow them on YouTube, Facebook, Twitter, Instagram, as well as their website. And if you have any questions that we didn't get to today, or if you live in the county and you're interested in some, or even if you don't, they have really great resources about wastewater and wastewater treatment and all of that. So I encourage you all to check it out. I would encourage you all to follow along with EarthEcho and our adventures as well. We did do an expedition back in 2017 called Water Design, where we looked at water scarcity and drought. We actually visited a water treatment plant in Orange County, California, and we drank some of that poo water. So you can check that out on our website as well. It tasted great. It was lovely. So don't forget to hit subscribe before you head out of YouTube today. And we want to thank you all so much for joining us, and stay safe and keep exploring. Bye, everyone.
Bye.